Hi everyone. So now we are going to be working with the topics under chapter 5, and chapter 5 is going to be about graphs, functions, linear functions, and of course linear systems. So our first topic is going to be about graphing and all about functions. So for this particular lesson, we are going to plot points in the rectangular coordinate system, graph equations also in the coordinate system, use function notations, graph them, use the vertical line test, and also given a graph, we can obtain some information. So let's start with some important vocabulary words. So when we're talking about graphing, we are always thinking of the rectangular system, rectangular coordinate system. Now remember that the horizontal line number, that is your x-axis, and you can see that there's this label over here. The vertical axis is the vertical line is the y-axis, as you can see from the label over here. Now, when those two axes meet, it's going to be at 0, 0, and that is what we call as the point of origin. Now, you will see that the negative numbers are either on the left side or below on our axis, and then the positive numbers are on the right side and upper part. Now, those axes, when they meet, you can see that they are dividing the coordinate system into 4 parts, which we call as quadrants. Okay. Now, when naming or identifying the quadrants, we do it counterclockwise. Okay. So the first quadrant, as you can see, all positive x, all positive y. Okay. And then from there, we move to the left side, go down, and then going to the right. So that is how we label our quadrants. So when we are talking about points in the rectangular system, they always come in ordered pairs. And when you have the ordered pairs, it's always mentioned as x, y. So for example, we have the points -5, 3, and also the second point, which is 3, -5. So you got to remember that the first number is the x coordinate. So it is the distance from 0 from the origin, and it is moving on the horizontal axis. So you can see here, -5 is this blue indication here. So -5 is up here, over here. And then 5, the second number, is the y coordinate. So that's the distance from 0 going up or going down. So as you can see, -5 and then 3 is going up. And on the other example, you have 3 is positive, so going to the right, and then -5 that is going down. So that is how we identify the points in our coordinate system. So let's talk about graphing of functions. So a relationship between two quantities are usually expressed in equations of two variables. Like for example, in this case, y is equal to 4 minus x squared. Okay, so as you can see, the equation are in two variables. We have two variables, x and y. So when we are looking for the solution of an equation in two variables, we have to find the value of x and y in such a way that if the x coordinate substitutes for x, and also if the y value substitute for the y of the equation, it can give us a true statement. Okay, so it's not just x that we are replacing now. We are also going to be finding out if we can make the value of y also true for the equation. So the graph of an equation in two variables is the set of all points whose coordinates, so the x and y values, satisfy the equation. So let's have this example here. So we are tasked to graph y is equal to 4 minus x squared. Now, sometimes it will be indicated that you start with specific numbers. So in our case, we are going to use the points, the value of x from -3 to +3. So you can see that we have our table here. We list down our x values on this column. Now here, we will replace the x into the equation so that we can get the value of y. And from there, this is the x, the value of y is over here, and then we can list down our ordered pair in here. Okay, so for example, from -3, we substitute x. So as you can see, it now is in red part. So y minus Negative 3 squared, that's 4 minus 9, which is negative 5. So our x is negative 3, and then the y value is negative 5. Okay? So negative 2, so we replace the x, so we get a negative 2, 0. If it is negative 1, we end up with a negative 1, 3. Okay? So these x values are the points. These are the x values that we have here. And then the y values are when we replace the x into the equation. Okay? So as you can see here, we get 7 points. And so if we are going to be graphing them, we will be using these ordered pairs to locate them on our coordinate plane so that we can see how the graph looks like. And so once you graph all those points, you will see that it is going to be a parabola facing downwards, as you can see here. So when you have those points, you try your best to join them with a smooth curve. In this case, it was curving this way. Okay. Now sometimes your points could go in a straight line, so just connect all of them. Okay. Now, whenever we're talking about graphs, we always hear the word functions typically together with it. Okay. So when an equation in two variables gives us a value for y, one value of y for one specific value of x, then we say that y is a function of x. So the notation, okay, you don't have to be worried about, Miss, what is f of x? It's just the same value. It's another representation for y, okay? So f of x is a function of x. Y is a function of x. So let's have this example here. So we have two functions that we're going to take a look at. The first function, so typically we name the first function with f of x, all right? So that is 2x. So this is just like y is equal to 2x, okay? So that's how we can get the y value. Now, if we have a second function, we usually use the next letter after f, which happens to be g, okay? So we have g of x is equal to 2x plus 4. So again, this is still y. This is equal to 2x plus 4, okay? Now, if you take a look at it, we have pretty much, it almost looks alike, except that the second function has a plus 4 at the end. So if we get our values for each x, our x values that we will use are negative 2 up to positive 2. So these are the values if from negative 2 to positive 2. So you can see that the x values are replaced here. So 2 times the x value, these are our y values now, and these are our our coordinate, our points that we will put in our coordinate system. Now, if we have it on the x, 2x plus 4, you will see that, okay, you can see that the x values are the same, all right? Negative 2, negative 1, 0, 1, 2, okay? Because we use the same x values. But if you take a look at our y's, okay, if you take a look at the pattern, this is a negative 4, and this becomes a 0, okay? Now, how come that happens? Well, we know that we had to add 4 to it. So negative 4 plus 4, that's going to be a 0, okay? If you take a look at this, originally it is a 2x, right? But once you have an addition of 4 there, then 2 plus 4, you get a 6, all right? Now, if we are going to graph these two sets of points here, this is how it would look like. So the blue line represents f of x. The purplish line is our g of x. And you would see that any point on the f of x pretty much goes up by 4 units, corresponding to the values, to the points in g of x, okay? And you can see that the plus 4 makes a huge difference with how the graphs look like. Now, when we are talking about functions, okay, we always have what we call as the vertical line test. And this is how we can know if a graph is a function or not. So pretty much the idea with the vertical line test is that if you draw a vertical line anywhere on your graph and it only touches one point out of that graph, then it is a function. The moment that it touches more than one point, then that graph is not a function. So if we take a look here in our examples, we have 4 graphs here. First graph, let's see here. you can see that anywhere you draw a vertical line, you will be touching maximum of 2 points. All right, maybe if you put it here, it will only touch 1, but somewhere else you always get 2 points that are passed through by the vertical line. So this is not a function. Okay, now this next graph, anywhere you do your vertical line, you only have 1 point intersected. Okay, so this is indeed a function. Similarly, for this graph here, anywhere you draw your vertical line, this is again a function. And in this case, you would see that it will be hitting our graph in 2 points. So this is not a function. So that's the simple way of checking if a graph is a function or not. So this time, we're going to be using the graphs to analyze some situations. So you can see here the graph, and this illustrates the body temperature from 8 a.m. okay, up to 3 p.m. So we are using X. So X is the number of hours, okay, after 8 a.m. And then Y represents the body temperature. So let's answer the first question. What is the temperature at 8 a.m.? Okay, now you cannot be looking at the number 8 on the x-axis because remember, these are the number of hours after 8 a.m. So this one represents 1 hour after 8 a.m., which means 8 a.m. is our 0. Okay, so the temperature when x is 0 is actually 101 Fahrenheit. Okay, so that's that. Okay, do not look for the number 8. Now, during which period of time is the temperature decreasing? So looking at the trend, so we know that decreasing is from a high point going to the low point. And in that case, it is going to be this part of the graph. Okay, and so which period of time? So it is asking between what times is it going to be decreasing? So we know that this is 8 a.m. and after 3 hours, the temperature was decreasing. So what is 3 hours after 8? So 3 hours after 8, so if you add 3, that's going to be 11 a.m. So there's a decrease of temperature from 8 a.m. up to 11 a.m. All right? So that's what this part of the graph is telling us. Next part, estimate the minimum temperature during the time period shown. So minimum, it's the lowest point of the graph. So it's going to be this point over here. And looking at it, it's roughly in between 98 and 99. So we can say it's around 98.5 or 98.6 Fahrenheit. How many hours after 8 a.m. does this occur? Now you can see that the lowest point happens 3 hours after 8 a.m., which is equivalent to 11 a.m. All right? So next part, during which period of time the temperature is increasing? So we can see from a low point going up, it is this particular area of the graph, and that is from 3 hours to 5 hours after 8 a.m. So if you add 5 to 8, that's going to be 13, and we have only 12 hours, so this is going to be equivalent to 1 p.m. So that is from 11 a.m. up to 1 p.m. That's when the increase is happening. So there is a horizontal line segment. So this one, what does the horizontal line segment mean? Well, because there was no change, it's not increasing, it's not decreasing. So it means that the temperature was steady, okay? The temperature was the same, okay? No change in temperature. And that's what that horizontal line means. And then explain why this graph is a function of x. Now remember, there's only one way to check that, and that's with the vertical line test. And as we can see, anywhere we put our vertical line, it will only, vertical line test, it will only be intersecting 1 point on the graph. Thank you.